Assalamualaikum and good morning to our lecturer and friend. Today we would like to present our project titled MOSFET Device Design and Fabrication Process Pbl. My name is Intan and with me are Amira and Diba. First, I will briefly explain the introduction. MOS technology is widely used in the modern electronic device because it allows the fabrication of the small SP and low power transistor. The MOSFET is a fundamental building block in the integrated circuit such as microprocessor and memory chip. An NMOS transistor consists of a p-type silicon substrate, two n-type region called the source and drain, and a gate electrode separated by the thin oxidized layer. When a voltage is applied to the gate terminal, electrons accumulate and form a conductive channel between the source and drain. Some advantages of NMOS device include high switching speed, simple fabrication process, high integration capability, VLSI circuit, and lower power consumption. Next, I will pass the presentation to Mira, who will explain the fabrication process.
Thank you, Intan. Now I will explain the MOSFET fabrication process. This process involves several important semiconductor manufacturing steps. First, the process begins with a p-type silicon substrate, which acts as the base material. Second, an oxidized layer growth process occurs where silicon deoxidized or silicon is formed as the surface to act as an insulting layer. Next is photolithography and etching, where patterns are created on the wafer surface using photoresist and light exposure. After that, the gate oxide formation is developed to create a thin oxide layer that isolates the gate terminal from the substrate. Then, polysilicon gate formation is performed to build the gate electrode. The next step is source and drain doping, where impurities are added to create n-type region. After that comes metallization, where metal layers are deposited to allow electrical connection. Next, metal contacts are formed to the source, gate and drain terminals. Finally, a passivation layer is added to protect the device surface from contamination and damage. Now, I will pass the presentation to Diba for the abstract and conclusion.
Thank you, Mira. Based on our abstract, the NMOS transistor is one of the most important devices in semiconductor technology. It plays a major role in both digital and analog circuits due to its high electromobility and efficient switching performance. The fabrication process includes several steps such as oxidation, photolithography, etching, diffusion, and metallization. Each step must be carefully controlled to ensure accurate device dimensions and proper electrical characteristic. For the conclusion, the NMOS fabrication process requires multiple control semiconductor manufacturing steps. Precision and process control are very important because small variation in temperature, doping, concentration, and layer thickness can affect device performance. Understanding the fabrication process helps students and engineers learn how semiconductor devices are manufactured and how they function in integrated circuit. That is all from our presentation. Thank you for your attention.